This is Geometry Lesson 1-8. The topic is perimeter, circumference, and area. Our objectives for today are to find the perimeter or circumference of basic shapes and to find the area of basic shapes. So we have some definitions to begin with. The first one is perimeter. The perimeter of a polygon is the sum of the lengths of its sides. The next one is area. The area of a polygon is the number of square units it encloses. And both of these are referred to as capital P for perimeter or capital A for area throughout the rest of this lesson. Now, our first one is a square. You've probably learned this at some point in time, but the perimeter is 4 times the side length and the area equals the side squared. Because all of the sides are the same length, that makes those formulas very simple to start off with. The next one is our rectangle. For rectangle, there's actually two formulas for perimeter. You could do 2 times the base plus 2 times the height, or 2 times the quantity base plus height, just depending on how you want to start the problem. Both basically just apply the distributive property in the first one. And the area is just the base times the height. The next one we have is triangle. A triangle, the perimeter is A plus B plus C, where A, B, and C are all the three sides of the triangle. And the area formula is area equals 1/2 base times height. The key is that the base and the height need to make that right angle that you see up there in that picture. Don't forget to find two pieces that make that right angle. And our last one is a circle. Circle, the circumference equals 2 pi r, or pi times d, where r is the radius and d is the diameter, and a is pi r squared. Now, one key feature to the circumference why you have two formulas is that 2 radian equal the diameter. So let's do some problems with this. Finding the perimeter of a rectangle. It says the botany club is planning to place edging on the outside of the path in the garden. How much edging material will they need? So if we're looking at this drawing, you have the garden on the inside and then you have this brick path. And so what we're trying to edge is that entire outside of this. I'm going to trace it in black. That is where our edging is going to go. So if we're trying to edge this, what we're looking for, area is a space enclosed. We're not looking for the space enclosed. We must be looking for the perimeter, which is if you were to walk around something or fence something in or edge something. If we're trying to find the perimeter, then what we're trying to find is the side lengths. This is a rectangle, and the rectangular formula is 2 times base, 2 times the quantity base plus height. So we need to know the base and the height of this garden. If you look, we know some measurements, we don't know of the inside, we don't know any measurements on the outside. You can take this right here and you can follow down those edges of the garden and say, oh, one chunk of the base is 16. And you can do the same thing with the one chunk of the height. You can follow over that 22 and you get between those green dashes is 22. So what we're looking for are these measurements from the corner to those green dashes. Well, that information can be found on the top of your diagram with that 4 feet. It's telling you that the path is 4 feet wide, so the distance from the edge to the green dash has to be 4. And it's going to be that way all the way throughout because this path is has the same width all the way around. So then, now that you have all those marked in, you can find the entire length, 4 plus 16 plus 4, that gives you 24 for the base, and then the height is going to be 22 plus 4 plus 4, which is going to give you 30. Now we're just ready to plug everything. 2 times the base is 24, plus the height is 30. We can solve for our perimeter to find the edging material now. 24 plus 30 gives us 54. 2 times 54 gives us 108. And we have to figure out, well, what's our unit? Go back, look at the problem. I see feet, so it's 108 feet. So that's a basic perimeter problem. Now we're going to talk a little bit about circles, how we name circles and how we refer to them. If you see that symbol right there, basically a circle with a dot in the middle, that is actually our symbol for circle. When we have a circle like that, we actually name that center dot A or some other letter, and we write circle A, just like you see in the notes. Now, circle formulas use this irrational number called pi, and basically pi does not have a terminating value. You may have celebrated pi celebrations on March 14th in math classes before. That's because pi is 3.14, etc. and March 14th is the third month, the 14th day. Now, we can approximate pi with the following numbers, 3.14 like I said, or 22/7. The key is that neither of these are exact forms of pi. We still don't, there is no exact form of pi. It is an irrational number, meaning that you can compute the digits of pi for the rest of your life and you will never actually find an end. Pi goes on forever and it never repeats. So a lot of times we end up leaving a pi in our answers, and so we'll say that something is maybe 22 pi feet or something along those lines. And so it may ask you to leave pi in your answers and you need to be okay with that. All right, so if you look back at a page in your notes, you can see the circumference and the area notes for a circle. We're asked to find the circumference of the circles in terms of pi, and what is the circumference of the circles in terms to the nearest tenth. So we're going to find it exact and we're going to find an approximation. Exact is in terms of pi. So your circumference formula, there's two of them, 2 pi r or c equals pi d. R is your radius, d is your diameter. Depending on which one they give you, you're going to use either one. Radius goes from the center to the edge. The diameter goes from edge to edge and goes through the center. So if we're looking at this first one, circle T, what they gave you right there is a radius that goes from the center to the edge. So we're going to use the radius formula, 2 times pi times 4. Multiplication, you can change the order, so you can actually go 2 times 4 and get 8 pi. And if you're leaving it in terms of pi, that's an exact answer. So we're going to say 8 pi centimeters. However, it also asks to the nearest tenth, so you're actually going to approximate it. When we approximate for pi, I ask that you use 3.14 for your approximation for the value of pi. So we're going to go 2 times 3.14, and we should get about 25.12. We're rounding to the nearest tenth though, so we're going to get 25.1 centimeters. Those are your two answers. If you could pause the video now and do the next one on your own. All right, you can see my answers up there. I got 15 pi inches in terms of pi, and then my approximate answer, 47.1 inches when I used 3.14 for my estimate for pi. The next thing they actually ask you to do is those same two pictures up there, we're going to find the area of each of them in terms of pi and the area of them to the nearest tenth. So I'm going to do the area just right below those those problems in blue. Area formula, regardless of whether they give you the radius or the diameter, it actually only uses the radius, so pi times radius squared. So you need to find the radius in order to find the area. So we know the area equals pi times the radius. We already knew the radius is 4 squared. We get 16 pi centimeters. Now area is two-dimensional, so it's squared. You get 16 pi centimeters squared then. Don't forget to square those units. Now we also want an approximate, so we're going to go 16 times 3.14, and our approximation for the area then is about 50.24. They ask for it to the nearest tenth, so we're going to round that to 50.2 centimeters squared. I want you to find the area for the next circle as well. The key on this one is make sure you find the radius first before you find the area. All right, you can see my answer for the second one up there. The radius is half the diameter, so I went 15 divided by 2 to get 7.5. Plug that in, I got in terms of pi, 56.25 pi inches squared, and rounded to the nearest tenth, 176.6 inches squared. All right. Oh, we did it up there. We had space down below. Let's move on to the next slide. Here we go. It says finding perimeter in the coordinate plane. What is the perimeter of triangle EFG? Remember, perimeters if you were to fence something or if you were to walk around something. So it's going to be, you're going to need to find the length of each one of those sides and add them up. Two of those three sides are pretty easy to find. GF and FE are fairly easy sides to find. GF, what you can do is you could either use our distance formula in the coordinate plane we talked about before, or you can actually count how far it is between them because it happens to be a horizontal line. So I'm going to count from G to F. I go 1, 2, 3, 4, 5, 6. And then we can also look from F to E. How far is that? Count it out. I'm going to count from F up to E. 1, 2, 3, 4, 5, 6, 7, 8. However, from G to E, because it's diagonal through, you can't count it out. What you actually have to do is go back to the previous lessons, lesson 1-7, and use the distance formula in the coordinate plane. If you don't remember the distance formula, I'm going to write it down now. I ask that you write it on your paper as well. It's the difference in the x's squared plus the difference in the y squared and the square root of the whole thing. So remember, we picked which ordered pair is going to be the first one, which ordered pair is going to be the second one. I'm going to make G the first one and E the second one, and then I'm going to start plugging in values. X2, X value from the second order pair, that's your 3. X1, X value from your first order pair, that's a -3. All of that squared, plus same thing with my Y's. Now I'm going to start simplifying. You can see as it starts to get simpler as we go. We should get that length to be 10. So the perimeter is all of those lengths together. You want to take these 3 lengths and add them all up. 6 plus 8 is going to give you 12 plus 10, or no, it's going to give you 14, not 12. It's going to give you 14 plus 10, that's going to give you a total perimeter of 24. Now, whenever we're talking perimeter or area, we always use labels, so we're just going to call it 24 units. This video is getting long, but we're almost done, so I'm going to keep on going with it. Finding area of a rectangle. It says you want to make a rectangular banner. The banner is 2.5 feet wide and 5 feet high. To the nearest square yard, how much material do you need? Now, notice the units. We start with feet, we end with yards. We start in 1 dimension, which is feet. We end in 2 dimensions, yards squared. So we're going to have to be careful in some of our conversions as we're doing this. Depending on the problem, you may want to convert into yards to begin with, or you may want to find out how many feet squared you need to begin with. Because this one's dealing with 2.5 feet wide, I don't want to deal with any more fractions in there, so I'm actually going to figure out how many feet squared I need to make this banner. So if you have your banner, it's 2.5 feet wide, and it's 5 feet high. To find the area, you're going to take 2.5 by 5, multiply those together. 2.5 is the same as the 2.5, so go 2.5 times 5, and you get a total area of 12.5 feet, or 12.5 feet squared. Now, that's in feet squared, but we want yards squared. So you have to think about, okay, 1 yard is 3 feet. 1 yard squared, how much is that? Well, that's really going to be 1 yard squared. It's going to be 1 by 1 for yards. But in each yard, there's 3 feet, so it's really going to be 3 feet by 3 feet. So the total area of that box in feet would be 3 times 3, 9 feet squared. So 1 yard squared is 9 feet squared. So if we're thinking about this, how much material do you need to the nearest square yard? Well, 1 yard squared is 9 feet squared, and we need 12.5 feet squared of material, which means we need more than 1 yard squared. If we're thinking in the context of this problem, if you're going to need enough fabric to make this, well then how many feet is 2 yards squared? 2 yards squared is going to be 2 squares of 9 feet squared for a total of 18 feet squared. 12.5 is in between 9 and 18. We would rather have too much than too little in this specific problem, so we're going to need 2 yards squared. We didn't actually round in this problem to the nearest number because it was a context problem, because if we only had 1 yard squared of material, we actually couldn't make our banner. So we had to round up. That's why we did that. All right, here's our last chunk, postulate 110, the area addition postulate. Basically, it says that if you have an irregular shape, like that one down there on the right, then the area of the entire shape is the sum of the area of the non-overlapping parts. So it means that I can take a weird shape like what I have over here, and I can cut it up into a bunch of smaller shapes. So maybe I see a square up there and a square down there and a square here in the middle. I can do that and I can find the area of each one of those on their own. Notice these little congruent markers, those are a big deal. That means those are all the same, so each one of those sides is 3, which is helpful because then you have one little square up here that's 3 by 3, 3 by 3 is 9. You have another little square down here that's 3 by 3, 3 by 3 is 9. Now if you're looking over at this medium square here, you can see that this entire side is 9, but I don't want the entire side, I only want a chunk of it. Because it's a 3 by 3 chunk on top, you can take away 3 and say that that side's 6. You can do the same thing on the bottom because you have this little 3 by 3 square. You take away 3 to get that side to be 6. 6 times 6 is 36. So to find the area of the whole thing, you're going to take those 3 areas, add them up. 9 plus 36 plus 9. That's going to give you a total area of 54, don't forget your labels, centimeters, and its area, so square it. That was a long video, sorry about that. This is Geometry Lesson 1-8. Our topics today will be able to find the perimeter or circumference of basic shapes and to find the area of basic shapes.